We're continuing our discussion of the benefits of control and data plane separation. And in this lesson we'll talk about the opportunities from control and data plane separation in terms of two examples. One is new routing services in the wide area in terms of maintenance, egress selection, and security. And the second is benefits in data center networks in terms of cost and management. So to remind you, this module has 3 lessons. We covered the overview last time, and in this lesson we will talk about opportunities in various domains that exist as a result of control and data plane separation. We'll then talk about some of the challenges and approaches to addressing those challenges for the control and data plane separation. So let's jump into the first example, which is benefits of control and data plane separation in the wide area. So if you know anything about interdomain routing, or perhaps you remember it from your undergraduate networking course, you may remember that policies, or ways to set policies in interdomain routing protocols, are very constrained. Today's interdomain routing protocol, the Border Gateway Protocol, or BGP, artificially constrains routes that any particular router in the network can select. That's because route selection is based on a fixed set of steps, and there are a limited number of knobs to control inbound and outbound traffic. It's also very difficult to incorporate other information, such as auxiliary information about the reputation of a route, time of day, and so forth. The separation of the control and data plane makes it a lot easier to select routes based on a much richer set of policies, because the route controller can directly update the state in the forwarding plane independently of whatever software or other technology may be running on the forwarding elements, or the routers and switches themselves. So let's look at a few examples. One example is called maintenance dryout. The idea here is that a network operator may want to do planned maintenance on an edge router. So in this example, let's suppose that the operator wants to do maintenance on the router sitting at egress 1. In this particular example, the operator could use something like the RCP, the routing control platform, to directly tell a router at ingress to send its traffic for a particular destination to egress 2. This would be much more difficult in today's networks because the network operator would have to use existing routing protocols to adjust the configuration of individual routers in the network to effectively tell all of them to switch their route from one egress point to another. This could be done in a lot of ways, most likely in tuning the intra-domain weights, for example the OSPF weights, on each individual router. But that's a very indirect way of doing this. It's much more direct to have a controller directly tell the router which egress point to use. The second example would be to let customers themselves control the selection of egress routers. So for example, if a particular customer wanted to use one data center or another to reach its particular services, again, the network could use the RCP to send traffic for one customer to one data center and another customer to a different data center. This would, by contrast, this would be very difficult in today's networks because BGP is routing traffic based on destination prefix. So if a particular service was served from a particular destination prefix, all of the traffic, regardless of customer, would go to the same data center. In this particular case, the RCP could route traffic to different data centers depending on the source, in particular, in this case, depending on which customer the traffic was originating from. As another example, we could imagine how separating the data in control planes could result in better security for interdomain routing. So while there are secure routing protocols that exist, many of them are very difficult to deploy. There are also auxiliary monitoring systems that can tell an autonomous system about the reputation or potential security or insecurities of a route advertisement, but there's no way to directly incorporate that information into BGP or interdomain route selection. So one idea might be to use an existing anomaly detection system to detect suspicious or bogus routes and to prefer familiar routes over unfamiliar routes. So if a particular autonomous system learned two routes to a destination D, one of which looked suspicious and the other which did not, the control plane, or an RCP for example, could tell the routers in that autonomous system to all prefer routing to that destination via the preferred route. By contrast, this would be very difficult to do in today's networks because there's no easy way to incorporate reputation information into the route selection process. Another area where the separation of the control and data planes can significantly benefit network operators is in data centers, and in particular, this separation can drastically reduce the cost of running a data center. Looking at a typical data center with about 20,000 servers and a fan out of 20 in the data center topology, we see that the requirements to support this topology is about 10,000 switches. If we take a particular switch from a standard vendor that costs $5,000, we're now talking about the cost of about $50 million just to deploy the switches. If, on the other hand, we could deploy commodity switches based on merchant silicon that cost only about $1,000, now we're talking about a switch deployment cost of about $10 million. So if we're talking about a large service provider that has 10 data centers, maybe a Google or a Yahoo or a Facebook, now we're talking about a savings of $400 million, which presumably you could use then to hire engineers to develop control systems for controlling those commodity switches. The benefits of that separate control result in more flexibility, the ability to tailor the network for specific services, and the ability to quickly improve and innovate, because as we've noted, once the control plane is separate from the data plane, it is a lot easier to control the behavior of the network because those switches are doing nothing more than just forwarding traffic, and all the smarts of the network are in the software control. Let's take a look in particular at how separation of data and control plane can make it easier to manage a data center through more flexible control in the context of addressing. So let's suppose that you have a data center with tens of thousands of servers and you want to figure out how you should address those servers. On one hand, you could use layer 2 addressing like Ethernet. This results obviously in less configuration or administration because if you've got one large layer 2 Ethernet, you can essentially just plug everything in and it's a flat topology. On the other hand, a flat topology with tens of thousands of servers clearly results in poor scaling because these layer 2 networks are typically broadcast. On the other hand, we could do a layer 3 network, and the benefits here are that we could use existing routing protocols and scaling properties are much better, but the administration overhead is a lot higher because we have to configure these routing protocols. For example, if we're using an intra-domain routing protocol like OSPF, then the network operator needs to configure the link weights in the topology and adjust those link weights accordingly to load balance traffic, account for failures, and so forth. So on the one hand, there are some conveniences to using layer 3 addressing or a topology-specific addressing like IP, but there are also some drawbacks like higher administration overhead. So how do we get the best of both worlds? Well, one idea is basically to use layer 2 addressing and construct a large layer 2 network, but to make those addresses topology specific rather than topology independent. And how might we do that? Because MAC addresses are typically flat. Well, the idea basically is we can use MAC addresses, but we can renumber or readdress these hosts so that the addresses of these hosts have MAC addresses that depend on where they are in this topology. Now, hosts can still send traffic to the other hosts' IP addresses in this data center topology, but the problem is that since we've reassigned the MAC addresses in the topology to be topology dependent, the hosts don't actually know that they've had their MAC addresses reassigned. They still think that they have their old flat MAC addresses. So, as we know, if a particular host wants to send traffic to another host's IP address, it will use the address resolution protocol, or ARP, to send out a broadcast query that asks who has a particular IP address. In other words, what is the MAC address for this particular IP address that I would like to send to? And the trick here is that we don't want the host, the destination host, to respond because it still thinks it has its old MAC address. What we can do in this case, because we have separate network control, is to use something called a fabric manager, or a separate controller, to basically intercept all of these ARP queries, or all these queries that are wanting to discover MAC addresses for particular IP addresses. So when this particular switch receives a query that says, tell me the MAC address for a particular IP address, that switch can kick that query to a central controller, or a fabric manager, which can then reply with the topology-dependent pseudo-MAC, or PMAC. And then all of the traffic can be rewritten with the appropriate source and destination topology-dependent MAC addresses. So that's just one example of how a separate controller in a data center can allow a network administrator to get the best of both worlds in terms of both topology dependence and the benefits of a layer 2 topology. We'll look at data centers a lot more in a particular module where we look at case studies of SDN later in the course. But this hopefully gives you a flavor of the types of benefits that separating control and data plane in a network can offer to network operators and administrators. There are a number of other opportunities that the separation of the control and data plane can offer to network administrators. For example, here at Georgia Tech, we're looking at how the separation of control and data plane can enable dynamic access control for campus and enterprise networks. And there are another number of other opportunities that you can see here listed out, many of which we will explore throughout the rest of the course. You can also check out the URL below here on the OpenFlow site to look at various videos that explore different case studies of how the separation of data and control plane can make network management and operations easier.